Trigonometric ratios, Part 1. Objective. Find the sine, cosine, and tangent of an acute angle. Use trigonometric ratios to find side lengths in right triangles and to solve real-world problems. Who uses this? Contractors use trigonometric ratios to build ramps that meet legal requirements. We might want to know what a trigonometric ratio is, though. A trigonometric ratio is a ratio of two sides of a right triangle. You'll notice that on your calculators they don't actually write out cosine and tangent. Sine is pretty close, they only dropped one letter. Well, sine is represented as S-I-N, cosine C-O-S, and tangent is T-A-N. Let's look at how we can apply these in triangles. Sine is always opposite over hypotenuse. I suggest always going through and labeling your hypotenuse first, so that way you know. For example, in this one here, we know that C, since it's across from 90 and it's the longest side, that's our hypotenuse. So that way I can just always have that written down. So since we want the sine of A, we're looking at this angle, this big angle A here. Sine is opposite. What's the opposite side of angle A? Well, the opposite side of angle A is side A. So we're going to have little a over our hypotenuse, which is C. So opposite over hypotenuse. If you look at the sine of B, it still follows the same pattern. The opposite side from the angle over the hypotenuse. Hypotenuse doesn't change. Notice which side is opposite depends on which angle you're looking at. The angle A is opposite little side A. Angle B is opposite side B. Well, let's look at cosine. Cosine is adjacent over hypotenuse. Now, if you look at angle A, there's technically two sides that are adjacent, B and C. However, you already labeled that C has to be the hypotenuse. It can't be both things. So the only side adjacent to A is side B. So we have B over C. For the cosine of B, we have our adjacent side, which is the side adjacent, that's not the hypotenuse, so little a, over our hypotenuse, which is C. So cosine is adjacent over hypotenuse. And tangent doesn't use the hypotenuse at all. The tangent of A is the opposite leg over the adjacent leg. So little a over little b. And if you took the tangent of B, that's going to be the opposite leg over the adjacent leg. So little b over a. So it's just opposite over adjacent. Opposite over adjacent. You might find this difficult to remember at first. So we have a nice little acronym to help us. SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. SOHCAHTOA. Finding trigonometric ratios. Write each trigonometric ratio as a fraction and as a decimal rounded to the nearest hundredth. So it's asking for the sine of r. In this case, it's just asking for a straight up fraction to a decimal. We're not actually finding angle measures here. So we want the sine of r. Well, r is, for sine, we want opposite over hypotenuse. So we want 12. So that's the opposite. And then our hypotenuse is 13. If you want, we can label that so we have it. So we have hypotenuse is 13 here. Okay, so we have 12 over 13. And then you can just utilize your calculator to figure out that that's about 0.92. Take a moment and try cosine of r and tangent of s. Now that you've had a moment to try cosine of r and tangent of s, let's try them together. Cosine is adjacent over hypotenuse, so the side adjacent to r is 5, so we have 5 over 13. 5 over 13 is about 0.38. Let's try tangent of s. Tangent is opposite over adjacent. So in this case, 5 over 12. And 5 over 12 is about 0.42. In a previous chapter, we learned about special right triangles. You can use special right triangles in trigonometry to help you out. So, we're going to try a 30, 60, 90 triangle together. We want to find out what the sine of 60 degrees is. So the sine of 60 degrees. Well, opposite 60 is s squared root of 3. Our hypotenuse is 2s. Our side opposite 30 is s. So if we want the sine of 60, we want opposite over hypotenuse. So we have s square roots of 3 over 2s. So we have sine of 60 is s square roots of 3 over 2s. But we can simplify this. We have s and 2s down here, so we can simply get rid of our s's and have the square root of 3 over 2. The reason you can do this is there's not a binomial or trinomial. You're just multiplying here. So there's no plus or minus between anything. So that's why you're able to cancel stuff out. Let's work on using a calculator. So take a moment and grab a TI calculator. Depending on your school, you might have a TI 30, a TI 83, TI 84. Any of those will work. The calculator that has appeared on the right-hand side of the screen is going to be used just to show you where the buttons are. So, when you're using your calculator to find a trigonometric ratio, we're also going to round to the nearest hundredth. So, the cosine of 76 degrees. The first thing you want to do is you want to make sure you're in the right mode. There are two different modes that can be used for trigonometry. One's called radian and the other degree. So if you go to mode on your calculator, you'll see a pull down screen where you've got normal, sci, English, then you've got float, and then right below that you've got radian and degree. You want to make sure the degree is highlighted, so you can use your arrow keys to kind of navigate that, and then once you have degree highlighted, you can just hit enter. If it already is highlighted, you're good to go, so just hit second quit. Now that we're all in the correct mode, we can now enter this into the calculator. So you'll see you have sine, cosine, and tangent. So for this one, we want the cosine of 76. So you type in cos and then 76. And when you do so, you end up with something that is about 0.24. You can do the same thing with sine of 8 degrees. So you would hit sine and then 8 and enter. So the sine of 8 degrees is about 0.14. Take a moment and pause the video and try to do C, 3A, 3B, and 3C. Okay, so the tangent of 82 is about 7.12. The tangent of 11 is about 0.19. The sine of 62 is about 0.88. And the cosine of 30 is about 0.87. That concludes part 1. Part 2 will actually apply the use of the calculator using our triangles.